Greetings and welcome to lesson 5.6. In this video, we're going to go over a general way to conquer factoring a polynomial. When we have a problem that we need to factor to solve, sometimes it's difficult to know where to start. So here are some guidelines on how to factor a polynomial. First thing you may want to look for is a greatest common factor. Once you factor a greatest common factor out, the problem gets slightly simpler. Secondly, you want to maybe look to see if it's a binomial, to see if it's the difference of two squares. If it's the difference of two squares, you can factor the difference of two squares using real numbers. If it's the sum of two squares, you're going to leave it as is in the real numbers. If you're in a higher level math class, then you can factor the sum of two squares with complex numbers. And what I mean by difference of squares, it's a squared minus b squared. And therefore we can factor it as a minus b, a plus b. If it's the sum of squares, a squared plus b squared, we're not going to factor that in the real numbers. So you can leave it as is. Third, maybe it's a trinomial of perfect squares. What I mean by trinomial of perfect squares is where it's a squared plus 2ab plus b squared. That way we can factor it into a plus b quantity squared. Or a squared minus 2ab plus b squared, that can be factored in a minus b quantity squared. So if it's into any of those, we can kind of quickly factor. If it is not one of the special trinomials, then we want to use either trial and error method, or in a supplemental video lecture, I did show you the X method. So you want to use one of those methods. If you have more than 3 terms, maybe you try grouping at least a few sets of those terms so you can break it down into a smaller problem. And then finally check to see if there's any factors that can be factored even further. Because once you get 2, let's say we get it into a 2 blob, just like this, 2 terms, you may think that you're done, but you really do need to look at your problem to see if it can be factored even more. Once you've done that, your problem should be as factored as possible. So thinking of those previous steps, how can we conquer this example, 2x to the 5th minus 8x cubed, and we can factor it, right? Remember, the first step, check to see if there's any GCF. In this case, the GCF is 2x cubed. Once we factor out 2x cubed, we get x squared minus 4. Oh, but x squared minus 4 is the difference of squares, because x is a squared, and 4 is a perfect square. Therefore, I can separate it out into x minus 2 and x plus 2. And now I want to take a look to see, can it be factored any further? Well, x is singular, 2 is singular, x is singular, 2 is singular, therefore no. I can't factor it any further. Let's try another one. 3x to the 4th minus 18x cubed plus 27x squared. Again, first step, let's look to see if the GCF can be pulled out. Well, 3 is definitely in 3. 3 is in 18 and 3 is in 27. So we definitely can pull out a 3. X squared, x cubed, and x to the 4th, x cubed, and x squared. They all have an x squared in it. So it looks like the GCF is going to be 3x squared. Once I pull out 3x squared, I get x squared minus 6x plus 9. Well, that's the square of x minus 3. It's perfect square. So I can factor it as 3x squared times x minus 3 times x minus 3. Or you can write it as 3x squared times the quantity x minus 3 quantity squared. One more example. Y cubed plus 25y. Again, factor out the greatest common factor. Well, I have y cubed and y. I can definitely factor out a y. So my greatest common factor is y. That leaves me with y times y squared plus 25, but that's not the difference of square, that's the sum of squares, so I'm actually done. There's no more than I can go at an elementary algebra level. If this was a higher level math, then we can get into the complex number realm and factor that further. But right now, in the real number sense, we're going to leave it as is. All right, this problem I'm going to show you two ways. Let me get that cord out of your way. 6a squared minus 11a plus 4. I'm going to go through the process and see what if I can pull out any greatest common factor, if it's a sum of squares, if it's anything special that I can break apart. So let's work through this one. 6a squared minus 11a plus 4. Well, I don't see any GCF, so I should be able to use the trial and error method. And after I show you the trial and error method, I'm going to show you that X method. So the first thing I want to do is I want to break apart the 6. My choices are 6 times 1 and 2 times 3 in some combination. 4, I do need a negative in the middle, so I do know my terms are both going to be negative. So it's negative 1 times negative 4 and negative 2 times negative 2. Now the only thing I can do in trial and error is try every single possibility. Well, 6 times 1, if my values are 6 and 1, then negative 1 times negative 4, that won't give me 11, because 1 times negative 1 is negative 1, and 6 times negative 4 is negative 24. That's not going to give me the negative 11. And then 6 times negative 2 is 12, 1 times negative 2 is 2, that's a negative 14. So none of those combinations work. I can rule them all out. Now I have 3 and 2, and I need to take every combination possible. So let's see, my negative 4 and negative 1, 2 times negative 4 will get me negative 8, 3 times negative 1 is a negative 11. So you can see where I'm going. It's just a lot of trial and error. 3 times negative 2 will get me negative 6. 2 times negative 2 is negative 4. That's negative 10. That's pretty much ruled out. There's no combination that will get me a negative 11. But let me switch it up and say 3 times negative 4 will give me negative 12. 2 times negative 1 is a negative 2, that's negative 14. 3 times negative 1 is negative 3. 2 times negative 4 is negative 8. Negative 3 times negative plus negative 8 is negative 11. There's my combination. So I know, using trial and error, it's going to be 3a minus 4, 2a minus 1. Now I find that method is so frustrating. So I'm going to use the X method. So off to the side, I'm actually going to multiply 6 and 4, which is 24, but I need negative, so I'm going to find all factors of 24, which would be negative 24 times negative 1. That's still positive, but that will give me a negative 25. Negative 12 and negative 2 will get me negative 14. And negative 6 and negative 4 will get me a negative 10. Negative 8 and negative 3, I skipped, would get me a negative 11. That's my combination. Now I'm going to rewrite the negative 11 as the negative 8 and negative 3. 6a squared minus 8a minus 3a plus 4. So this side work was just to break up the middle digit, or the middle term, into something that I can group. Now I'm going to group, and I probably could have grouped it the other way a little bit easier, and I'm going to change it. I'm going to say that's 3a and that's 8a, right? Just because I know 3 goes into 6 really easily. So 3, pull out the a, and I'm left with 2a minus 1. Pull out a positive 4, and I'm left with 2a minus 1. Pull out the 2a minus 1 as a factor. That leaves me behind 3a plus 4. Same answer, but I think this way is a little bit faster. Okay. All right, using our plan of attack, let's factor 2ab to the 5th plus 8ab to the 4th plus 2ab cubed. First things first, greatest common factor. My greatest common factor now is going to be 2ab cubed. If I have 2ab cubed, I am left with b squared plus 4b plus 1. Now I need to look, is there anything else that I can two numbers that multiply to 1 but add to 4? If there are no two numbers that can multiply to 1, well, 1 times 1, but 1 plus 1 is only 2, therefore we're done. It cannot be factored any further than what it is. Let's attempt to factor x times y plus 8x plus 3y plus 24. Now this candidate, because it has 4 terms, looks like it's very good to do grouping. So I'm going to group just as is. I'm not going to reorder anything. I'm just going to group it as is. And now for each group, pull out its common factors. The first xy plus 8x, its common factor is x, leaving me x times y plus 8. 3y plus 24, common factor is going to be a 3. 3 times y plus 8. Oh, well, x has a y plus 8 and 3 has a y plus 8, so I can factor a y plus 8 out, leaving me y plus 8 times x plus 3. So that's it for this video lecture. Until next time, be seeing you.